So I'll be talking about Spyre. It's a web application framework for Python. If anybody here has lived in the R world, you may have heard of Shiny or use Shiny. It's a very similar package for R. It's basically just a very easy way to turn data and plots into interactive web applications. Spyre depends on Cherry Py to provide a server in the backend, Jinja 2 for templating, so you don't have to write any HTML or JavaScript, Matplotlib for the basic plots, and pandas because we're working with data here. Assuming you don't have any problems with those dependencies, to install Spyre, you just do pip install data Spyre. And this is going to be a very example-driven talk, so if you want to follow along, I encourage you to do so. We'll start just by talking about kind of the mechanics of how to create an app and how to launch it. So from Spyre, you import the server module, and that server module has an app class. So every app that you create, it's going to be a class, and it needs to inherit the server app class. So to create an app, this is all you do. I don't recommend launching this in IPython Notebook. The recommended way to launch an app is just from the command line. So here's that empty app that I just showed you. And to launch it, we just do Python, the name of the file. And I know this is probably hard to see, but this will give you some feedback and tell you where it's being served. So this is being served locally. And if we copy that into our browser, we get an app, which is empty right now because we haven't put anything in it. But we'll walk through a couple of examples to show how to build these one piece at a time. So the first thing we need to do is add inputs to our app. Inputs, outputs, and controls are all just lists of dictionaries. Each one of those elements is a dictionary specifying the properties of that element. So in this case, we want to add a single input. It's going to be a text box. So input type is text. And then it's got some properties like a variable name, a label, an initial value. So if I run this, and refresh this page, I've added an input, just a text box. If we want to change the input type, we can just change that property, save it, and reload the page. And now it's a slider. So next we'll add an output. We're just going to add a plot. Like the inputs, outputs is just a list of dictionaries, each one of those dictionaries specifying the properties of the outputs. In this case, the output type is a plot. We've got an output ID, and we want this to load when the page loads. So we'll have on page load is equal true. Save that. And now when we refresh, we have an output. Which has no content because we haven't told the app what should be in the output. And so we'll do that next. So to create the content for any of the outputs, you need to override a method that comes with the server app. In this case, we need to override the getPlot method. And so the getPlot method is going to take some inputs, which are supplied by the inputs in your panel over here. And it should output a PyPlot figure. So you see the getPlot method takes params as its only input, and params is a dictionary which is going to hold all of the input values. It's keyed on the variable name. So in our inputs, we have a variable name as one of the property keys and values. In this case, the variable name is freq, because we're going to have a sine wave that we're going to plot. So we define f as the freq value of the params dictionary. Most of these inputs come back as strings, so if we want them to be anything else, like an integer or a float, we need to cast it as such. Here we're just defining the x-axis and then creating a pie plot figure. So now with the getPlot method overridden, we save and reload our page, and now we have the plot. And if we change our input value, the plot updates. So notice that the inputs and outputs not only specify what types of elements to include on the page, but also how they're connected to each other. So part of the properties of the inputs is an action ID, and that tells the app when this input state changes, I want to update whatever this action ID is pointing at. In this case, the action ID is pointing to our plot output. So the output ID for the plot is plot sine wave, and that action ID references that output ID. So a very simple app, very simple relationship. An update to the input state tells the output to update. And briefly, just kind of one piece of what's going on under the hood here. Spyre uses Jinja 2 templating to generate the HTML and JavaScript. So basically, there's a bunch of templating pieces that look kind of like this. When you pass in the inputs and the output dictionaries, Jinja renders those into the HTML and JavaScript that creates the page you're looking at. If this is boring or uninteresting or foreign to you, that's okay. You don't need to know anything about HTML or JavaScript. All you need to know is Python to create a web application with Spyre. Okay, so let's build on this and look at a slightly more interesting example. So let's suppose you've written a function to go to the web, get some historical stock data, and turn that into a data frame. So that's what this getData function does. It takes a ticker value, so the symbol that represents whatever company you're interested in. It goes to the web and turns that into a pandas data frame. So this function here returns a data frame. Once you have a data frame, pandas has a nice method called plot that's really, really simple to use and creates nice looking plots of the data in the data frame. So here's the data we're getting back from this API that we're hitting, and just calling plot on that data frame returns this plot for us. So once you've done that work to get the data and create a plot, we're going to now turn that into a web application that's interactive. Okay, so as before, we define a single input and a single output. The output again is a plot, but in this case we're going to use a drop-down menu, so we just do input type drop-down. And then rather than having a single value, a drop-down menu has an option of values. Each one of those has a label, which is what you see in the UI, and a value, which is the value passed to the getPlot method in this case, when that option is selected. This getData method here is just exactly what we saw before. It goes to the API, grabs the data, turns it into a Python data or a pandas data frame, and then getPlot is just the app method that we need to override to actually generate the plot. So in this case, getPlot is calling the getData method, and then just returning a PyPlot figure. Okay. So we update our app script, save it, and now when we reload, Thank you. Gotcha. All right, now when we relaunch that app, reload the page, now we have that plot that we were seeing before and a drop-down menu input. So as we change the company that we want to grab data for, the plot calls the getData method to go to the API, grabs the data, and turns it into a matplotlib plot. So architecturally, this is similar. It's the same as the first app that we built. It's a single input, a single output. They communicate directly through the action ID of the input and the output ID of the output. If you wanted to add a second output, that's definitely possible, but it becomes a little bit more complicated in terms of how things talk to each other. So again, we're going to add a table this time as the output. So the input is the same as we had before, except this time we don't have an action ID. So a change to the input will not create a change in the output. Instead, we're going to have a control. And controls are anything that have an action that can update output. So in this case, our control is going to be a button. The action on this button is to click it. So clicking the button is what's going to trigger an update to the outputs. So we have the plot output again, and now we've added an output type of table. So these look kind of what you would expect them to look like. The only thing that we've added is a control ID. And this control ID is a reference to the control that's going to trigger an update in the output. So the control ID here is update data, which is the control ID for that button that we created. All right, so if we save that and refresh our page, we get two outputs, the plot that we saw before, and now this pandas data frame has been turned into a sortable HTML table. So if we click on any of these columns, they're sortable. If we change the input, nothing happens until we click the button, and then clicking the button updates both of the outputs. I should mention that just like with the plot, we had to override the getPlot method to actually generate the content for that plot. For a table, the actual content comes from a getData method, which we've conveniently already created to get the data. So this getData method is actually the thing that's generating the content for the table. And that's expected to return a pandas data frame, which is why you need pandas for Spyre. Okay, finally, we will add two more things. So it can get a little bit crowded if you have a lot of outputs in one panel. So you can add tabs to your app, just like with inputs and outputs. Tabs is a list of things. In this case, it's just a list of tab titles. And then each output now is going to live in a tab, so it needs to reference the tab that it lives in. So within each of these output dictionaries, we now have a reference to the tab. So the plot output is going to live in the plot tab, and the table output is going to live in the table tab. We're also going to do a little trick such that a change in the input now updates both outputs. So each input only has a single action ID, so you can only directly update a single output with a change to the state of the input. However, the action ID can reference either an output ID or a control ID. So if we reference the control rather than the output directly, then a change to the state of the input is essentially taking an action on that control. In the case of a button, it would be like clicking the button whenever you change the state of the input. By doing so, you basically make the existence of the button superfluous. So to not confuse anybody, we can actually have a hidden control type, which basically just routes the action of the input to the outputs that we want. So if we save that and refresh our page, now we have both of our outputs but in different tabs. And we no longer have a button. A change to the input routes our action through a control to both of the outputs. So kind of what that looks like in a diagram. We have our input, which has an action ID, which references a control. And that control, an action on that control is what actually updates the output. So we're indirectly updating the outputs through a change in state of the input. So these are just two very simple examples. There are certainly cases, much more complicated cases. And I think the best way to really dig into this is to look at the examples. There are a ton of them on GitHub within the examples directory. There's a live running example of this at adamhajari.com. This is basically just the stocks example that we ran through. It's got the plots and the tables. Another output type is HTML. There are also two methods that you can override called get custom JS and get custom CSS. So if you wanted to do something fancy like supply your own JavaScript through a package like Bouquet, you could do that. And so there's a Bouquet plot that we're generating by supplying some HTML, JavaScript, CSS. You don't have to write any of that. Bouquet actually writes it all for you. You just need to tell the Spyre app where to get it. There's an example of that in the GitHub repo. But this works just like you'd expect, except you have all the nice functionality. Oops. Of Bouquet. Great, and I guess I didn't say this yet, but I'm Adam Hajari. I'm a data scientist at Next Big Sound. And you can contact me or follow me on Twitter. So that's all I've got. Are there any questions? Yeah. To render the what? I think I used something called sortable, sort table. Yeah. Pandas actually has a method called toHTML, which will turn your data frame into a table. But to make it sortable, you need to use the get data method. I definitely haven't hit the upper limit yet. I've loaded a data frame of 5,000 rows before, and that seems to be fine. It's slow, but it's past 5,000. I'm not sure what it would be. Yeah.
Can you show an example where the styles
Where it's styled to be something different than
yeah, so it's like it's got to be pretty
I don't have an example. I spent all my time just styling the generic version of it. But you can definitely pass in your own CSS and change the color of the buttons or the style of anything if you want to override any of that style. It doesn't replace it, it just adds it. So it'll add it. And play it. Sorry, I don't understand the.
like with templating, like I could put something that's generated a variable inside of, in an inner element of the HTML that I want.
I see. Like you want to put a plot figure inside of HTML.
That's right.
Yeah, you can definitely do that. So these are just to generate all of this stuff. It's hard to do with one hand. So there's just a call to the table input endpoint, for instance, to generate the table. So if you were to put this input or this endpoint into HTML, it would just put this table into whatever HTML you want to surround it in. Does that make sense? Yeah.
Just a comment that your final example was something that I spent, I'm not sure, several weeks arguing in my first reference case, so I wish that was
Yeah.
it's clearly like filling
Yeah, and that was actually, I started out in the data science world using R, and that was one of the fact that R had Shiny was one of the things that kind of kept me in the R environment. It was just so easy to turn your, whatever project you're working on into a client-facing web app. And I should mention that by default, this serves up the web app locally on port 8080. You can override those in the launch method. So if you wanted to host this to external traffic, you would just do host equals 0.0.0.0, and then put it on whatever port you want it. So if you want it on a port 80, you could do that. And then you could put it on an EC2 instance or wherever you want to give it to a client or anybody externally. Yeah. I mean, it's by design. It's simple. It's supposed to be very simple to get it off the ground in no time at all. So it's not. Yeah, you could have as many inputs and outputs as you want. So in that sense, it scales well. But it's not designed to be the web page for your company, right? It's designed to make simple web apps to export to somebody that you want to see the data, but don't necessarily want to see the code that generated the data. That's a great question. So the params dictionary here has all of the input values, but it also has an output ID key. So if you have two plots, they're both going to call getPlot, but within getPlot you would have if output ID equals output 1, generate this plot. If output ID equals output 2, then generate this other plot. And I actually was a little bit sloppy here in my simple example. I called the GCF method, which is get current current figure. That doesn't work if you're generating more than one plot. You actually need to create a figure object and then return that in getPlot. So don't do this. Don't do the GCF method if you have more than one plot. Yeah. Yeah, there's not an easy way to do that now, and I haven't really experimented with it, but an idea that I had is there are libraries to connect to Google Docs. So for instance, you could have somebody create a Google spreadsheet with their data and then reference it through this interface. So they would just supply like the URL for their Google Doc, and that could generate the data for you. Yeah, and hopefully somewhere down the road we'll have functionality to actually upload your own data, but that's kind of something we haven't built yet. Great. Well, thank you guys for listening.